Module 8. Gases and the Gas Laws. Gases are one of the three states of matter and are characterized by their ability to expand to fill any container. In a gas, the distance between the particles is very large relative to the size of the molecules. In this chapter, we will explore the relationship between temperature, pressure, and volume of gases, various scientific laws that govern the behavior of gases, the ideal gas, and the extent to which ideal gas laws have practical applications. Relationship between temperature, pressure, and volume of gases. The behavior of gases is influenced by several factors, including temperature, pressure, and volume. The combined gas law is expressed as P1 times V1 divided by T1 equals P2 times V2 divided by T2, where P1 is the initial pressure, V1 is the initial volume, T1 is the initial temperature, P2 is the final pressure, V2 is the final volume, and T2 is the final temperature. The combined gas law is used to relate the pressure, volume, and temperature of a gas under changing conditions. It combines Boyles' law, Charles's law, and Gay-Lussac's law into one equation to describe the behavior of a gas when two or more of these variables change simultaneously. If any of the factors, volume for example, is not referenced in the equation at all, both instances, V1 and V2, can be replaced with a 1. Pressure and atmospheric pressure can affect gases in several ways. When a gas is subjected to pressure, its volume will decrease as the gas molecules are compressed together. Conversely, when the pressure on a gas is reduced, its volume will increase as the gas molecules expand to fill the available space. Atmospheric pressure is the pressure exerted by the weight of the Earth's atmosphere. It can affect gases by pushing down on them, making it more difficult for them to expand and occupy a greater volume. Atmospheric pressure also affects the boiling point of liquids, with lower atmospheric pressure resulting in a lower boiling point. Greenhouse gases. The presence or absence of certain gases directly impacts everything around it. For example, greenhouse gases impact the entire world. Global warming is the gradual increase in the Earth's average surface temperature, largely due to the increase in atmospheric greenhouse gases caused by human activities, such as burning fossil fuels, deforestation, and industrial processes. These greenhouse gases, such as carbon dioxide, methane, and nitrous oxide, trap heat in the Earth's atmosphere and prevent it from escaping into space, resulting in a rise in global temperatures. This process, known as the greenhouse effect, occurs when the greenhouse gases absorb and re-emit infrared radiation, which warms the Earth's surface. As the concentration of greenhouse gases in the atmosphere continues to increase, the greenhouse effect becomes stronger, causing global temperatures to rise and leading to a wide range of impacts such as melting ice caps, rising sea levels, and more frequent and severe weather events. Scientific laws governing the behavior of gases. Several scientific laws govern the behavior of gases, including Boyles' Law, Charles's Law, and Avogadro's Law. Boyles' Law states that the volume of gas is inversely proportional to its pressure. This is because when the volume decreases, the gas molecules are closer together and they collide with the walls of the container more frequently, causing an increase in pressure. Charles's law states that the volume of a gas is directly proportional to its temperature. Avogadro's law states that the volume of a gas is directly proportional to the number of particles in the gas. The ideal gas. An ideal gas is a theoretical gas that follows certain assumptions, including having no volume or intermolecular forces between particles. In reality, no gas is truly ideal, but many gases can be treated as ideal in certain conditions. The ideal gas law is used to describe the behavior of ideal gases, and it assumes that the gas is in a constant temperature and pressure. Practical applications of ideal gas laws. The ideal gas law has practical applications in several fields, including the chemical industry and environmental science. It can be used to calculate the amount of gas needed for a chemical reaction or to determine the effects of gases on the environment. The gas laws also play a role in engineering and the design of engines and turbines.